Ladies and gentlemen, we're going to continue our discussion of chirality, that's handedness. And there's a special kind of molecule out there that has multiple stereocenters, like this molecule. Each stereocenter has a red group, a blue group that I'm holding over there, a green group, and a carbon with a red, blue, and green. Say the same thing over here, a red group, a blue group, a green group, and a carbon with a red, blue, green. It's kind of unique in that both stereocenters have the same groups. And as a result, you might think molecules with stereocenters are going to be chiral. They're going to be handed because they have these handed objects in them called stereocenters. This one is not chiral at all. I'm going to prove it to you. Ready? There's only one definition of chiral. Can you read it back to me? Maybe you didn't write it down. It was on the previous. Oh, I remembered it. A molecule is chiral if it's not superimposable on its mirror image. That's the only definition you wrote down. So I made the mirror image of this molecule, although it was a waste of time because I'll show you why. Clearly their mirror image, look. They're looking across the mirror at each other. See? Yeah. But when I do this, and I put them on top of each other, this is not like my left hand on my right hand. Green matches green here. Green matches green here. Red's on top of red. Red's on top of red. Blue's right on top of blue. They're identical molecules, everybody. There's no distinguishing this from this. All the parts match up. Can't do that with my hand. Mirror image. Try to match them up. That's pretend my pinky's green and the thumb is red. Green does not match red, right? Green doesn't match red over here either. So special molecules can have stereocenters and not be chiral. These molecules are easy to spot. Take a look at this molecule. There's a mirror plane in the molecule right there. My hand is a mirror plane, isn't it? What does green see across the mirror plane? Green. What does red see across the mirror? Red. What does blue see across the mirror? Blue. This molecule has it's called a mesoplane, and that makes it achiral, which means it does not have an enantiomer. I tried to make its enantiomer, and I proved they were identical by superimposing them. Every mesomolecule in the world, that's true. They will superimpose on their mirror image. That means they're identical to their mirror image. That means that's not a new isomer. Okay? It's the same molecule. So we have it. So we have a little wrinkle to our formula from before. Here's the little wrinkle. Mesomolecules have an internal plane of symmetry. That's one thing they have. And multiple stereocenters that cancel each other across the plane. Cancel each other. And when I say cancel each other, I'm talking about a phenomenon we're going to see on our next activity called optical rotation. Okay? And if one stereocenter rotates light this much, it's a special kind of light, then the opposite rotates at the same amount but the opposite direction. So putting that special light through the sample, it'll rotate when it hits one of the stereocenters that way, and then when it hits the other, it comes back to normal because it rotated the opposite way. And they cancel each other. So it will behave just like a molecule like water. Water's not chiral, right? Water's identical to its mirror image, right? And it doesn't have any stereocenters. You can't say it's meso, but it's achiral. So this molecule would have no chiral behavior, handed behavior. And I believe one of our isomers that we're about to draw is going to be meso, and you'll see it. So we're supposed to draw all isomers of 4,6-difluoro, 4,6-diisopropyl nonane. So follow steps. And it didn't say which one we had to draw first. And on your test, you're not told which one you have to draw first. Like RRS. Your choice makes your life a lot easier. Okay, we like it. We're just going to do the stereocenter as easily as we can. I'm going to put the 4 on the dash already. I'm going to connect them, and I'm going to tell the teacher what it is, RRS. First of all, I'm going to start by drawing nonane. 2, 4, 6, 8, 9. Go to carbon 4. There's 2 groups on it. Go to carbon 6. There's 2 groups on it. If I do it this way and put the dash here and here, I'll tell you why in a second. I'm going to put the groups on like this. I got difluoro and I got diisopropyl. I think you can see the mesoplane when I draw it that way. Can you see it? No, I didn't want to grab that. You're being mean to me. Temporary adjustment here. There. I just wanted to copy this crazy thing. There's my drawing for the question. Here is my lecture item. This here is a mesoplane right through that carbon. Mesoplane. Half of a carbon is on the other half of the plane is another half of the carbon. You can cut a carbon in half. On the dash, there's a propyl group, the same distance from the mirror as this propyl group. See it? Propyl, propyl. Fluorine on a wedge away from the mirror. Wedge away from the mirror. Up. Isopropyl. Hey, this molecule doesn't have a mirror image. Meso. Don't draw the mirror image. So in terms of strategy, from the last page, if there's a meso, just leave it blank. It would have been right there. If you drew the mirror image of that molecule, you would have just drawn another copy of that molecule. I'm going to take a point off because you told me it was unique. You were wrong. But I did have a strategy for drawing a diastereomer of this that was III. So once again, this is confusing when I do it this way. A is for this question. I and II are for your previous activity. And III was to redraw the first molecule and do what? What's the one little change you're going to make? Single switch on one stereocenter. Please make sure you follow that exactly. You want to make it the first stereocenter every time, make your life easy? Why not? So here's the first stereocenter. I'm going to put the isopropyl on the wedge and the fluoro there. Then I'm going to copy this stereocenter as is. And I didn't do RRS on my first one. I will. I should have done it before I moved on. 1, 2, 3, 4. That's R. And the mirror image of R is S, Hey, if you've seen that it's meso, you don't have to do all the steps. You go ahead and do them. You're going to see it fast. And you did a single switch on an R. Now it is S. Didn't do anything on this. It's still S. And what was the strategy for your last molecule? Mirror image of what you just drew. It's good strategy. Put the fictitious mirror up. Not the prettiest, but it's it. And the mirror image of the blue S is the blue R, and the mirror image of the red S is a red R. Yes. For the meso one's mirror image is identical to what you just drew. So here's the meso one. Here's how I knew it was meso. You don't have to draw it and put the meso plane on it to know it's meso. You look at your molecule. You look at your molecule. Pretend I want to ask the question, is this thing meso? Want to do that question? And I'll show you why the answer is no. In a meso molecule, you need to have the stereocenters cancel each other. You need as many R's as S's. You clearly don't have any S's. This can never be meso. Same thing here. So you don't have to have the visual on it. You just have to identify the fact that the stereocenters have identical groups, fluoro, isopropyl, propyl, and then the rest of that molecule. And that's the same groups as on the other stereocenter. You're not a meso candidate unless your stereocenters have the same groups across the molecule. Okay? Like for our example, our first molecule was not meso. First one today. These groups see each other. If this is a potential meso plane right here, but isoheptyl does not match an H. They're not the same. So it's not meso. Okay. Same groups. I mean, the name, you know, there's same groups on each carbon. All right. 4,6-difluoro, 4,6-isopropyl, nonane. I could do a quick change to make it not meso at all. You want to see it? Change nonane to decane. And if you did that, your molecule now goes like this, and you would have to draw the mirror image because a butyl group on the right side does not match a propyl group on the left side. Okay? So you'd have 4 molecules now if this was decane instead of nonane. I got to get rid of that 10th carbon because this isn't decane. There you go. So. And comparison. Let's just do them all in black. No, there's no black highlighter. We got a comparison between those two and these two and these two. There's only one E. Which label gets E for an enantiomer? Bottom one. The others are, how do you say the other one? Some of the stereocenters are the opposite. Some stayed the same. Diastereomer. 12 points this time. 3 less comparisons and 1 less molecule and 2 less stereocenters. So the cut 6 off. You'll find a couple mesos in history of old tests. Mostly it doesn't happen on this question because I want you to get as many points as you can. Typically it's the full 18 like our previous one. And on the back of this one, we'll do a mini activity if it ever saves. Yeah. There we go. Meso M achiral because meso. Oops. That's no good. Meso and achiral because meso. Then we have chiral, CH, and achiral, not meso. We'll go achiral, not meso. Label each one. Molecule. So here's one. And we'll do like this. And yeah. Okay. So pretty sure one of these will be meso. You don't have to copy the molecules, everybody. Sorry. You just need the labels. We'll put, so you'll put A and then one of those labels, and then B, one of those labels. We'll do 4. This morning we used Newman. Maybe I'll do a Fisher. We haven't done a Fisher at all this semester. So we'll do. Hi. Yeah. And the show. Okay, sounds good. And I don't know if you've drawn it like this, there's no way to draw a mirror plane. I really suggest you don't try to do the mirror plane to see if it's meso. You do the R's and the S's. Do we agree that each stereocenter has a propyl, a bromo, a hydrogen, and 2 carbons, and then the other stereocenter, which was identical? Do we agree? It's a meso candidate. So is this, but only one of them is going to be meso. Trust me. One that has 1 R and 1 S will be the meso one. The one that's either RR or SS will not be meso. That's the easiest way to do it. And we'll just do a quickie. It's S on top and S on the bottom. So that's your CH. Your answer for A is CH. That's all you need to draw. I'll highlight it for you. Just chiral. Didn't change stereocenter 1, so it's S. 10, dude. I did a single switch on the other one. I mean, what are you going to write for this one? Which one? M. Meso. It's achiral because it's meso. Highlight that. Yeah. And then down here. Oh. This is called a Fisher projection. We need to learn this because we probably haven't already. It is a real time saver. I'm going to draw it out, what it really means. And you're going to say, wow, I really respect that Mr. Fisher let us do this. That's what it means. And if you want to be real picky, all the vertical bonds, all the vertical bonds are what kind of bonds? Dashes. And all the horizontal bonds are wedges. Yeah, and what's my textbook say about the fashion statement that'll help you remember that? Oh, there's a fashion statement mentioned in your textbook that helps you remember if it's drawn left to right, it has to be wedges in a Fisher projection. Well, there's a fancy item you can put on your neck that goes from small to big. It's small in the middle and big outside. What is this thing? Gentlemen typically wear it more than ladies. Bow tie, said the lady. Nice. Okay. And most jackets, especially winter's coming, right? What's going on with that? Zippers, they're vertical unless you're into the big boss, but you know, just talk normal zippers, they're up and down, right? I got one, I'm not going to show you, that would be inappropriate. Should have brought my jacket. I could ask her to demonstrate, that's fashion, but I will not. I think you got a zipper, right? Yeah? It's zipperless? Oh, it's a pullover. Okay, never mind. Yeah, you busted me. I don't have my glasses on. Guys, are you going to make me do R and S on this one? Sometimes the meso is pretty obvious, isn't it? That's a meso plane, isn't it? I mean, that OH is right across the mirror from another OH. They're both out in front. So are the H's and so are the CH2OH. So we're going to put a big old M for that one too. Highlight it. And in a Newman, if you just rotate front C 180, so back C, same. Back C, didn't touch it. Front C rotated 180, so CHO is now right in front of CHO. OH, OH, H. Do those groups match up in front of each other, the H and the OH? No, not meso. They'd have to be identical. Just good old chiral, huh? What was the short form? Just CH? CH. And the giveaway was right here. I guess the giveaway here for meso is the meso plane. Once again, though, you could have done the R and S on this. And when you do, you get S and R, S here and R here. That is another way to do it. You'd have to do, well, wedge just means the answer is wrong when you go 1, 2, oh no, it goes 1, 2, 3. It's not R, therefore it's S. Yeah. 1, 2, 3, not R, therefore S. And 1, 2, 3, not R, not S, therefore R. I agree. And meso. Yes, sir.
Yeah, the last one, no, we kind of rotated negative 60.
Well, you can get, yes, you could have got negative 60 to match the OHs. I'll do it. And but H would be on top of an aldehyde, which doesn't match. And similarly, the aldehyde would be on top of this H. Yeah. Yeah. Whatever way gets at least two groups right in front of each other. So I just chose to have the aldehydes right in front of it. It's a meso candidate. You got to have one of them matching, right? Or else you're not trying. So I got the aldehyde to match, but the others did not. So if you wanted the meso version of this, I think with the OH over here and the H over here, that would do it, right? Same exercise would have H in front of H and OH in front of OH. And I think that's all we need for the mesos.